Hello everyone. Today we are on exercise 5.2 of the chapter Playing with Numbers. And the question number 1 in this exercise is construct a 3x3 magic square to get a magic sum of 93. So let us move to the solution of this problem. And we have in this on page number 15 of the study material the solution for question number 1. It is, if the magic sum is 93, then the middle number will be 31. That is, it will be 93 divided by 3. That is 31. We have to divide that magic sum by 3. Now we have to choose 4 numbers greater than 31 and 4 numbers smaller than 31. So let us take 23, 25, 27 and 29, which are smaller than 31, and take 33, 35, 37 and 39, which are greater than 31. So in both the cases of numbers below 31 and above 31, what we have done, we have taken numbers with a constant difference of 2. So there is a gap of 2 between, say, suppose 23 and 25, 25 and 27, 27 and 29. Again, for the higher numbers, there's a gap of 2 between 33 and 35, between 35 and 37, and between 37 and 39. Now we'll construct a square 3 cross 3 with additional boxes on the left side and the right side, and onto the top and at the bottom. So we'll write the lesser than 31 numbers from the left side, that is 23, in the ascending order, in the increasing order, as 23, 25 and 27, and the greater than 31 numbers as 35, 37 and 39 onto the right side. Now what should be the next step? Then we know we have to swipe these numbers. We have to bring in these numbers. We'll take 23 to the opposed blank box here to the right, and we'll take this 39 to the left blank box. Similarly, we'll take that top number 27 to the opposite below 31, and this 35 that is at the bottom, we'll take it up above 31. Okay, so this constructs our magic square, and we can see in the second step we have developed the magic square. This way we have got the required magic square. So this was about question number 1, and then we have question number 2. So let us see what does question number 2 ask us. Question number 2 asks us, construct a 4 cross 4 magic square starting from 20. What is the magic sum of the square constructed? So we had to construct a 4 cross 4 magic square starting with 20, and we have to find its magic sum as well. So let us move to the solution now. Again, we are on page number 15, question number 2. Here is the solution. As we have to construct the 4 cross 4 magic square starting from 20, our 16 consecutive numbers will be 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34 and 35. Now we will find these numbers we will fill these numbers in a 4 cross 4 grid. So write in the first row 21, 22, 23, 20, 21, 22, 23. In the second row we'll write 24, 25, 26, 27. In the third row we'll write 28, 29, 30, 31. In the fourth row we'll write 32, 33, 34 and 35. And we know how to do the second step now. Now we have the first diagonal elements as 20, 25, 30, 35. And the second diagonal elements as 32, 29, 26 and 23. So we'll now oppose these diagonal elements. We'll reverse their order, as we'll keep the bottom right at the top left. So we'll accordingly change the trend of the numbers. So we'll write 35 here, then 30 here, then 25 here and 20 here. And similarly we'll change the order of the numbers of the second diagonal, as we'll keep at the left bottom 23, then to across it we'll keep 26 and then 29 and then 32. So we have changed actually what is called it as transposed. We have transposed the diagonal elements, and we have kept the other numbers untouched. That is 21, 22 in the first row is untouched. 24, 28 in the first column is untouched. 27, 31 in the fourth column is untouched. We have not done anything. We have not changed the positions. And 33, 34 in the fourth row are unchanged. So this was the second step. So this way we get the required magic square, whose magic sum will be the sum of the four numbers in the center of the square. In the center square we have numbers as 30, 29, 25 and 26. The sum comes out to be 110. So the magic sum of this 4 cross 4 grid magic square is 110. So this was about question number 2. Now we are moving up to the page number 3, page number 16 now, and there we have question number 3. And in that first part, we are supposed to find the divisibility. We are supposed to find the divisibility by 2, 3, 5 in the all the parts of question number 3. So first number in part A, that is 3A, is 120. So we have to check its divisibility by 2, 3, and 5. So let's take 120. What is this 120? It's an even number. And is this even number divisible by 2? Yes, it is divisible by 2. Now, second step, 120. What is the sum of digits of 120? 1 plus 2 plus 0, that is 3. Is that sum divisible by 3? Yes. So the number is divisible by 3 as per the rule. 120. What is that one digit of the 120? 120, that is 0. So is that divisible by 5? Yes, that is divisible by 5. That means the number 120 is divisible by 5. Similarly, you have numbers as 729. You will apply the same rules to find out whether they are divisible by 2, 3 and 5. Okay, so I'll keep this part B, part C and part D for your homework. So you had to apply the same divisibility rules of 2, 3 and 5. Then we move to question number 4. There we have a set of 1, 2, 3, 4, 5, 6 numbers, and we are supposed to test their divisibility by 2, 3, 5, 9 and 10. Previously we just now did divisibility by 2, 3 and 5. So 9 divisibility rule, you know the sum of the digits must be divisible by 9, and 10's divisibility rule you know as well, that is the units place must be 0. So again you can do this question yourself. So this is also a kind of exercise for you. You will do it yourself. It's quite easy and you can fill in the box quite easily. Now we move to question number 5. And what does question number 5 ask us? Let's check it out. Question 5 asks us if the number, that's a 4-digit number, 32A5. 32A5 is a 4-digit number. If the number 32A5 is divisible by 3, if this number is divisible by 3, then what could be the possible value of A? What can be the possible value of the digit at tens place in this case? So let's try to understand this problem. So if the number in question number solution of question number 5, now on page number 16, if the number 32A5 is divisible by 3, then we have the sum of its digits must be also divisible by 3. That is 3 plus 2 plus A plus 5 is equal to a number divisible by 3. So let's sum the 3, 2 and 5. That comes out to be 10. 10 plus A is equal to a number divisible by 3. So 10 plus A is equal to, first option will be 12, second option will be 15, third option will be 18. So A is a digit, so it cannot be greater than 9. It cannot be greater than 9. So we're picking up values of A as 2, 5 and 8. So the possibilities of the digit at tens place, that is A, are 2, 5 or 8. Now let's move to question number 6 now. What is in question number 6? Similar type of question is there as well. If 5, 6b, a 3-digit number, is multiple of 9, then what could be the possible value of b? What could be the possible value of b? So if it is multiple, and it's also must be the divisible by 9 as well. So let us move to the solution. If 5, 6b is a multiple of 9, then we have 5 plus 6 plus b is equal to, that's 11 plus b. Simple. If as b is a digit, it cannot have value greater than 9. Now we need a multiple of 9 which is greater than 11. We can see 18 is the only number satisfying both conditions. Hence, b is equal to 7. So 18 is the sum that is divisible by 9 close by. So, and for that, b must be equal to 7. So this was about question number 6. Now let us take question number 7 now. Using the divisibility rules for numbers 2 and 3, create a divisibility rule of number 6. Use the rule to find whether the numbers 4, 5, 6 and 7, 8, 9 are divisible by 6 or not. So let's move to the solution of this problem now. So we are on page number now 17. The divisibility rule for 2 says if the ones digit is 0, 2, 4, 6 or 8 or the number is even, the given number is divisible by 2. The divisibility rule for 3 says if the number of the digits is divisible by 3, the given number is divisible by 3. Using the above two rules, one of the possible rule for divisibility for 6 could be if the number is even and the sum of its digits is divisible by 3, then the number is divisible by 6. Suppose 4, 5, 6. It is a number. It's an even number. And 4 plus 5 plus 6 is 15. The sum of the digits is divisible by 3. Hence, it is divisible by 6. Let's verify. When we divide 456 by 6, yes, exactly, it is divisible. We get the quotient as 76. Now, let's take one more example. 7, 8, 9. It is not an even number. Hence, it is not divisible by 6. Though the sum of the digits is 24. That is divisible by 3. Let us verify. When we divide 7, 8, 9 divided by 6, it comes out to be 131.5, which is not divisible by 6. So hence you conclude that for divisibility of 6, the number must be even and it must be divisible by 3 as well. So let's move to the summary now. We have concluded the chapter and I hope that you must have understood the concepts, though it was a rigorous chapter and it needs a lot of practice. You keep on practicing and it will be done, inshallah. So let's move to the summary now. In summary, what we have, the general form of a two-digit number is 10x plus y, where x not equal to 0 and y can take any value between 0 and 9. Second, the generalized form of a three-digit number is 100x plus 10y plus z, where x is not equal to 0, while y and z can take any value between 0 and 9. Then we have, if the digit at the ones place of a number is 0, 2, 4, 6 and 8, the number is divisible by 2. Next, if the sum of all the digits of a number is divisible by 3, then the number is divisible by 3. Next, if the digit at the ones place of a number is 0 or 5, the number is divisible by 5. Next, if the digit at the ones place of a number is 0, the number is divisible by 10. And last but not the least, if the sum of all the digits in a number is divisible by 9, the number is divisible by 9. Thank you very much. This way we have concluded the chapter playing with numbers.